In this lesson video, we will first introduce index law 7 regarding negative power. Here we will consider two scenarios: negative power on a normal term and negative power on a fraction form term, that is where both numerator and denominator are within the scope of a negative power. And then we will practice a number of example problems on algebraic expression simplification using index laws 1 to 7, that is all the laws that we learned so far. In this section, we will learn index law 7, where we will learn how to handle negative power. So for example, here x is the base and the power is minus n, that is negative power. So x to the power minus n, we can write it as like 1 divided by x to the power n. So that means if we have a negative power, we can convert it into positive power by dividing that base and power 1 divided by that. That means just bringing it at the denominator. Or if we have a positive power in the left hand side, we can take it as the denominator as the negative power. So let us illustrate how these things happen with a simple example. So if we have x square means multiplication of 2x, and x to the power 6 means multiplication of x 6 times. 1, 2, 3, 4, 5, 6. So now if we divide it, that means x square division x to the power 6, we will get 2x's multiplication at the numerator and 6x multiplied at the denominator. So now if we cancel 1x, 2x, then at the numerator we will get only 1, and at the denominator we got 4x multiplied, and we know 4x multiplied means x to the power 4. That means x square division x to the power 6 equals 1 by x to the power 4. Now index law 2 says that x to the power m division x to the power n equals x to the power m minus n. So if we apply this division law in this case, that means x square division x to the power 6, we will get x to the power 2 minus 6, m minus n. So numerator's power minus denominator's power. So we will get x to the power minus 4. That means calculation of the same thing, x square divided by x to the power 6, in one way we are getting 1 division x to the power 4, and calculation of the same term x square division x to the power 6 using index law 2, we are getting x to the power minus 4. So these two things must be similar. That means we can write x to the power minus 4 equals 1 divided by x to the power 4. So that means we can make a negative power positive by taking it into at the denominator. Or we can write like this: if we think the denominator is 1 here, so if we take this denominator on the upper side, on the left hand side, and this numerator if we bring it on the right side as denominator, then we can write the same thing, that is x to the power 4 is going on the left as the numerator. So we can write x to the power 4 equals, if we take this x to the power minus 4 on the right hand side, it will become denominator, so it will be x to the power minus 4. That means index law 7 is saying that if we have a x to the power anything to the power minus power, we can take it as the denominator 1 upon, and we can make that negative power positive. Or if we have a positive power or a negative power at 1 divided by something negative power, we can take it at the numerator becomes positive power. So that means index law will be used to convert between negative power and positive power, and positive power and negative power. Let us see, for example, here how we can use index law 7, that is for negative power. In this first example, a b to the power minus 1. Here the power is minus 1, negative, and this power is only on B, not on AB. It is actually B to the power minus 1. So A has nothing to do with this minus power. So here we can write A will remain as it is. Anything to the power minus 1, we can make it 1 divided by that power's positive. So B to the power minus 1, we can write it like 1 division B to the power plus 1. That means 1 by B. So if we multiply these two, A times 1 by B, we will get A division B. In this second example, unlike this first example, where minus power was only on B, but here explicitly a bracket is given to notify that this minus 1 power is on this total AB. So here the base is, only B, but here the base is AB, and this minus power is given there. So what will happen here? It will be 1 division, the whole base will come down. That means x to the power minus n. So 1 division this base and then the power. So here for this minus 1, AB is the base. Whole AB is the base. So this whole AB will come down, and this power 1 minus 1 will become plus 1. So we can write it like 1 power 1 means 1 time multiplication. So here a square b to the power minus 3, if we take this minus power on the top, then a square times, we know that if we take a minus power, negative power on the top, 1 upon negative power, we can take it as a numerator positive power. So for example here, x to the power minus n, if we take 1 division x to the power minus n, if we make it numerator, it will become positive power. So here a square times 1 division b to the power minus 3. A square division b to the power minus 3, we can write it like a square times 1 division b to the power minus 3. So if we take this b to the power 1 division b to the power minus 3 on the top, that is at the numerator, then we will get a square b to the power plus 3. So this 1 upon b to the power minus 3 going on the top, it will become b to the power plus 3. In this example, this numerator got a to the power minus 2, denominator got b to the power minus 3. So if we write like this, a to the power minus 2 times 1 division b to the power minus 3, this is b. So now a to the power minus 2, if we make this power positive, it will go 1 division a to the power plus 2, and 1 upon b to the power minus 3, if we take this minus power on the top, you will get b to the power plus 3. So we will get 1 upon b a square times b cube. That means we will get b to the power 3, because here the denominator is 1. So b to the power 3 and 1 will be multiplied, and a square and 1 will be multiplied. So we will get b to the power 3 a square. So in this for example, we learned how we can convert a negative power terms into positive power terms.